So I thought I would create a video on the working solutions to the homework that was assigned in Unit 5.4, graphing transformations of sinusoidal functions. So let's look at the first question. Y is equal to 3 sine 2x minus 45 quantity plus 3. So it might not be clear is that there's an implicit set of brackets there. Wrong place. Let's try this again. Okay, so I thought I would create a video of the working solutions for the homework from section 5.4 on graphing transformations of sinusoidal functions. So let's look at the first question. So this one is a little bit tricky because there's an implied set of brackets in there. So 3 times the sine of 2x minus 45 degrees plus 3. So what I like to get in the habit of doing is breaking down my a, k, d, and c values. So in this case, a is 3, k is 2, d is 45. Again, I like to think of it as what makes inside that bracket, adding subtracted to x, what makes that 0. So in this case, d is 45 degrees, and c is 3. So from there, we get the various attributes of sinusoidal functions, such as what we list to the left. Just be wary that get in the habit of doing this. You may not get this information on a test. You may just be given an equation, a grid, and just asked to sign it. So, graph to sign, asked to graph the function. So you have to sort of remember these attributes and sort of remember that we need all these attributes to graph it. So in order to get the period, this is where we need the k value. So the period is going to be 360 divided by k. In this case, 360 divided by 2, which is 180 degrees. And I mentioned in my last video, or in the video in the lesson, was that in order to get the scale, remember our sinusoidal functions are broken up into 4 equal parts. So that's why we're going to take my period and divide that by 4, and we get a scale of, in this case, 180 divided by 4 is 22.5. No, take that back. 180 divided by 2 is 90, divided by 2 is 45. So let's go off and label the scale. So that's 45, 90, 135, 180. Then just to the left as well. Although I can see I'm not going to leave, this is not going to need it because this is a phase shift to the right. So that's the next part. Because my d value is 45, my phase shift is 45, and since it's positive, it's going to be to the right. The amplitude is simply the absolute value of my a value. So in this case, I'll write it down explicitly. In this case, the absolute value of 3, which is 3. So remember, amplitude is always positive, and the vertical shift is we get from my c value. So that means the is 3. So that implies the equation of axes is 3. So y equals 3 because that's the equation of a line. And as I highly suggested, as we go off and graph this, always sort of put in the equation of axes so that we could get a rough idea, or so we know exactly where the graph is going from. So let me do this in red. So we have a phase shift of 45 degrees to the right. So that's along right here. And since we're graphing sine, we know that sine starts at the equation of axes. So it's going to be starting right there. And then because it's just a normal sine, it's not reflected, the next point is going to go up. So in this case, we're going to go up by amplitude of 3. So we go from 3 to 6, which is roughly right there. Then we come back down to the equation of axes, coming down 3, and that puts us on the x-axis, and back up 3. So that's our 5-point technique for graphing a sinusoidal curve. And then we just connect it with a nice smooth sinusoidal curve, and that's what our graph looks like. Okay, so for the rest of the questions, I'm not going to go that much into detail. But when there's something that might be different, in other words, there might be reflection, I'll slow down and explain that a little bit more. So let's look at the next question. So this one, the k is not factored out for us, so I'm going to rewrite this equation. So it's going to be 2 times the cos of 3x minus 60 degrees plus 4. So here my a value is 2, my k value is 3, my d value is 60 degrees, and my c value is 4. So my period is going to be 360 divided by k. In this case, it's 3. So it's going to be 120 degrees. And in order to get my scale, we do 120 degrees divided by 4 is 30 degrees. So we're going to tackle the phase shift right away as well. So this is going to be 60 degrees. Since it's positive, it's going to be to the right. And the amplitude is simply my absolute value of my a value. In this case, is 2. The vertical shift of my c value, which is 4. So that plays my equation of axes is y is equal to 4. So let's put it in my scale. Now that I got each tick is 30 degrees. So 30, 60, 90, 120, 150, and 180 degrees. I'm not going to go to the left because I see the phase shift is to the right. Whereas my equation of axes is y is equal to 4, so it's going to be up there. And let's go plot off 4 points. So in this case, this shifted 60 degrees to the right, so that's somewhere along there. And because this is a cosine, so just a little reminder, maybe I should have did that at the very beginning. What does our parent function look like? So again, this for sine starts the equation of axes, goes up, back down to the equation of axes, back down, and back to the middle. So there's our parent function for sine, and likewise I could do the same thing for cos. Cos starts at our peak, comes out the equation of axes, down to the trough, equation of axes, and back up to the peak. So cos parent function looks like that. So let's go back down and look at our question. So cos is going to start at our peak, so we need to find our equation of axes, which is 4, go up by the amplitude, which is 2. So it gives me a point there. Then cos comes down to the equation of axes, down 2, back to the equation of axes, and back up to the peak. And that's what our graph looks like for that transformation. Okay. So that's why we give you so much of this homework, because really it's the same thing over and over again, but it's just good for us to get that practice in recognizing the different shifts and graphing the different sine or cosine. So here we have an actual reflection, so this one's going to be interesting. Again, I need to factor out my k value, so it's going to be negative 2 sine 4x 180 divided by 4. I got my calculator. Well, the 180 divided by 2 is 90 divided by 2, so this one is plus 45 minus 3. So my a value here is minus 2, k is 4. My d value in this case is minus 45 degrees. Again, the easy way to remember that is what makes that 0. And then my c value is minus 3. So my period is going to be 360 divided by k. In this case is 4, which is 90 degrees. My scale, again, is going to be 90, my period divided by 4, which is 90 divided by 4, which is 22.5. The phase shift in this case is going to be 45 degrees, but since d is negative, it's to the left. And the amplitude is the absolute value of a. In this case, it's 2. And the vertical shift, oh, that's weird. How do I get rid of this? So the amplitude is 2. And the vertical shift here is negative to my c value, which is negative 3. So that applies to my equation of axes is y is equal to minus 3. So let me just quickly draw that in since I got that. And let's put it in our scale. So every tick is 22.5. So I'm actually going to go by 2. So I'm actually going to go by 2. And here, this is going to be 45 degrees, 90 degrees, and 135 degrees. You could label the ones in between as well, but since it's decimal in there, it could get a little bit cluttered, so I'm not going to do that. Since this is shifted to the left, I'm going to label to the scale to the left as well, so there's negative 45 degrees. So because this one is sine, so there's negative 45 degrees, there's my phase shift, so it's going to start at the equation of axes because we have a reflection in the x-axis because A is negative. Instead of sine going up, it's actually going to go down, in this case by an amplitude of 2, so it's going to take me to negative 5. Then it's going to bring me back to the equation of axes, then up 2, and finally back down to the equation of axes. So there's our sine curve. It's going to look just something like that. Okay. So let's move on to the next one. So we have a cosine. Again, we have a k value. So we need to factor this one out. So this thing is the same as minus 1/2 cos. When we factor out a half, we get left with x minus 180 degrees, because 90 divided by a half is the same thing as 90 times 2 plus 1. Okay, so my a value is negative 1/2. My k value is 1/2. My d value, in this case, is 180 degrees, and my c value is 1. So my period, again, our equation is 360 divided by k, and k is actually here is 1/2, so same thing as 360 times 2, which is 720 degrees. So my scale is always going to be divisible by, divided by 4, so 720 divided by 2 is 360 divided by 2 is 180, so my scale is going to be 180. My phase shift is my d value, 180 degrees, in this case is positive, so it's to the right. The amplitude is the absolute value of my a value, so my a value here is negative 1/2, so the amplitude here is actually 1/2, and the vertical shift, in this case, is my c value, so that's 1, so that applies my equation of axes is y is equal to 1, so let's put that in. So this one's going to be a little bit tricky because the amplitude is quite small. Because I already have the y-axis labeled, we're going to keep it. But if it wasn't labeled, I might label every tick as 1/2 or even 1/4. But anyways, let's go and put in the scale for the x-axis. So there's 180 degrees, 360, 540, 720, 900, and 1080. So here we got a phase shift of 180 degrees to the right. So that's going to be just one tick over. So again, we're starting at equation, looking at our equation of axes, but here we got the cos. So cos normally starts at the peak, but because this is reflected, it's actually going to start at the trough. So it's going from the equation of axes down 1/2. Will be there. Then we go back to equation of axes up to our trough, which would be 1/2, would be roughly around there. Back to equation of axes, in this case down to the trough. I think I said trough here. That's actually the peak. My bad. There's a trough right there. So we can see that this equation is very compressed vertically. So here is what the cosine, or sorry, the graph would look like here. Let's look at the next question. So this one is a little more straightforward for us. We actually have the k factored out for us already, so we don't have to do any factoring. So let's go off and list the a, k, d, and c. So a here is just a -1. K is 3. D is going to be -45. degrees, and C is going to be a positive 4. So my period is going to be 360 degrees divided by K, in this case is 3, so it's 120 degrees. So my scale, we take our period, divide that by 4. Sorry, that looks a little bit messy. Let me clean that up. 120 degrees divided by 4, so my scale is going to be roughly 30 degrees. My phase shift is going to be 45 degrees. Since D is negative, it's going to be to the left. The amplitude in this case is 1, and the vertical shift is 4. So that implies that the equation of axes is y is equal to 4. So let me sort of draw that in. So this one is a little bit tricky because as we go off and label our scale, it's 30. So every tick is going to be 30 degrees. So it's going to be 30, 60, 90, 120. And I need to do to the left because I see it's going to be shifted to the left. So let's do minus 30 degrees, minus 60 degrees. So the reason why this one is tricky is because my phase shift of 45 degrees is not an exact multiple of my scale. Thankfully, it is sort of in between. So in between 30 and 60 is 45. So basically we're going in between each of the ticks on my x-axis. So let's go off and look at this. So this was as a sine. So it's going to start at the equation of axes. So here, right here, that is, I think I can do this. Nope. So right there is the negative 30. So right in between negative 30 and negative 60 is going to be negative 45. So that's where my point will be. And because the sine is going to start the equation of axes, again, we have a reflection because A is negative. So instead of going up, we're going to go down. In this case, we're going to go down a value of 1 because that's my amplitude. So that might bring me down. That would bring me down over here. Again, right in between, exactly halfway between my hash marks. And then sine is going to go back up. So it's going to be right there. And then finally hits the peak. So again, right between my ticks on the x-axis, and finally back at the equation of axes. So our graph would look something like that. So again, that one was a little bit tricky only because our points weren't exactly on the ticks of our scale on the x-axis. All right, for this next question, again, in this case, we don't actually have, or the k value is 1, so we don't have to factor on anything. So let me write out the attributes, A, K, D, and C. So A is 2, K in this case is just 1, D is 60 degrees, and C is minus 3. So in this case, the period is 360 degrees divided by K, which is just 1, so the period is just 360 degrees. So our scale is just going to be every tick is 90 degrees. We have a phase shift of 60 degrees to the left. And then we have the amplitude of 2. And the equation of axis, or the vertical shift, is 3. So that implies the equation of axes is y is equal to minus 3. So let's draw the equation of axes there. So again, we're going to run into a similar issue in terms of my scale is at 90 degrees, but the shift is not exactly 90 degrees. So again, we recognize, or hopefully recognize, that 60 is sort of like 2/3 of 90 degrees. So we're basically going 2/3 in from our ticks on the x-axis. So we're dealing with a cosine. So here we're going to start at the peak. So we're giving, so I forgot to label the scale. So let's put the scale in. So that's 90, 180, 270, 360, and 450. So we see that if it's shifted 60 degrees to the left, so let me put in this the scale on the left side as well. So there's, oops, not negative 60, negative 90. So if we want to go 60 degrees to the left, we're not going to quite go there all the way over here, but roughly 2/3 across. So here might be somewhere around there. And because cosine is starting at the peak, so we get to equation of axes go up to, so that's going to be -1. And then likewise here we go approximately 1/3 across. We hit equation of axes, 1/3 across. There's a trough, back to the middle, and finally we hit our peak again, and there's our graph. Okay, so here I'm not going to look for preciseness exactly. Are you exactly at -60? I could tell you we're roughly in 2/3 here, so that's good enough. If we were given a longer grid, a workaround for this is actually getting a multiple that's both of 60 and 90 for our x-axis, which would be 30 degrees. Unfortunately, with this graph, the grid that we're given, there's not enough ticks to go all the way up to 360. So we had to kind of keep it at 90, but it still works. We could still do it. This next question. Again, with here we have to factor out the k. So this is going to be the same thing as 3/2 sine of 4x plus 360 divided by 4 is 90 minus 1/2. So my a value here is 3/2 or 1.5. K is 4. D is minus 90 degrees. And my C is minus 1/2. So lots of halves in here. My period is going to be 360 divided by my K, which is 90 degrees. Here my scale is going to be 90 degrees divided by 4, which is 45, 22.5. My phase shift is going to be -90 degrees to the left. Oops, so it's not -90. The phase shift is, so phase shift is always positive. But in this case, because D is negative, it's to the left. And the amplitude in this case is 3/2, and the vertical shift is minus 1/2. So that implies my equation of axes is y is equal to minus 1/2. And I'll sort of dot that in. So the reason I kind of laughed is because the phase shift is 90 degrees to the left, but my period is 90 degrees. So really, the graph is not shifting at all. I'll graph the full thing, but hopefully you can kind of see it as well. So here, let me do the scale. So in this case, every tick is 22.5, so I'm going to do every 2 is 45, 90, 135, and on the near side is minus 45. Okay, so this was a little bit hard to do because my phase shift is 90 degrees to the left, which would bring me way over here somewhere. Okay, but because the phase shift is the same as the period, it really hasn't shifted at all. So what we're going to do is basically a phase shift of 0. So we're going to start at x equals 0 and start graphing this. So because it's sine, it's going to start the equation of axes. It's going to go up by my amplitude, which is 1.5. So here's 1/2 and then 1. Back down to my equation of axes. I'm going to bring it down to -2. And then back to my equation of axes. And the graph will look like this. And you can see if I kind of extended this graph and continue this pattern, it will look like that, there, and then finally somewhere over here. So if we shifted it 90 degrees to the left, that's where it would start, but recognize that at over here, it's really the same part of the graph. That's where it starts repeating itself. So a little bit of a trick question. Finally, this is the last one. Yep, last example. So here we have the k value that's actually factored out for us. So here my a value is -2. K in this case is 3 over 2. My d value is -65 degrees. And my c value in this case is 0 because nothing's going to be added or subtracted. So let's look at this. My period is going to be 360 divided by 3 over 2, which is the same thing as 360 times 2/3, which is 240 degrees. My scale, therefore, is going to be 240 degrees divided by 4, which is 60 degrees. So every tick is going to be 60 degrees. My phase shift is going to be 65 degrees to the left. Since the d value is negative, the amplitude is 2. If the vertical shift is 0, so that applies the equation of axes. Equation of axes is y is equal to 0, or really our x-axis. So this one, again, is tricky because my scale is 60, but my shift is not exactly a multiple of 60. In fact, this one's even more difficult because it's not even like a third or a halfway. It's just like a smidgen, a little bit more or less than 60. So let's see how we could graph that. So let me go off and label our scale. So 60, 120, 180, 240. And I know this is going to be shifted to the left, so let me label it to the left as well. Oops, that's going to be -120. My equation of axes against is my x-axis. We're dealing with cos. So it's going to start at the peak, but again, because my a value is reflected, it's actually going to start at the trough. So we have to go down 2 from the equation of axes. The question is how far, where's my x value? So here we can see that at this tick, it's 60 degrees. It's going to be slightly to the left of it. That's going to be 65. Again, I'm not looking for exact position. All as long as I'm looking for is that you are not exactly on the tick. You're just a little bit to the left. So our next point for cos, oops, sorry. That's supposed to be starting at the trough. So let me get rid of that point. Starting at the trough, so which is -2, which is bring us down over here. And then cos is going to bring us back to the equation of axes. So again, not right on the y-axis, but a little bit to the left. Then it brings us to the peak. So maybe right there. Back down to equation of axes, so just to the little bit left of that tick. And then finally back down 180, slightly to the left of that. And that's where our graph looks like. And there's our graph of that function. So again, a little bit tricky, but hopefully you saw some strategies and what I did in order to get the points. And more importantly, when your phase shift is not the exact same multiple of your scale, I'm not going to look for exactness, but just an approximation. All right, so hopefully this was helpful in for you to sort of check your homework, and if you didn't get the correct answer, hopefully my description helped you out in that.